today I want to present you the OSIC Fellows, the first round of the OSIC Fellows that have contributed a lot to open science and also have done an amazing job during the hackathon. Among them, we have Han Sang, Stefan Hoynes, Martina Vilas, and Marta Topol. The first fellow I want to mention is Martina Vilas. She is a PhD candidate in the Max Planck Institute in Germany, in Frankfurt, and she is investigating how the brain represents abstract information using computational models. She also really enjoys talking about computational reproducibility and contributing to open science projects. We have Stefan Hoynes. He is a research data and software engineer at the Psychoinformatics Group, also in Germany, and he is working on tools for decentralized research data management. He's passionate about brains, open source and open science, educational tools, and inclusive communities. Marta Topor is a PhD candidate at the University of Surrey, investigating performance control processes in neurodevelopmental motor disorders, and she gets excited about different methodological solutions in research. She is an advocate for collaborative and supportive academic science. For this session, the last OSIC fellow is Han. He is a research scientist at the A-STAR Research Center in Singapore, and he is working on brain and behavior development in childhood. She is very interesting in the social brain of young children and really enjoys promoting open science practices in the Chinese community. Now I want to show you their presentations.
Hello everyone, Han here. Thank you so much for coming across this lightning talk. I'm very appreciated this opportunity to share my personal journey regarding to open science. So here we go. Before I summarize our personal vision and contributions to open science, please allow me to introduce myself. I'm now a research scientist with Singapore Institute for Clinical Sciences, and I'm really proud of a working mom who is very interested in child brain and behavior, especially its influencers and how to prompt better developing. If you are in a similar trend, I will be grateful to have a contact with you. Now I want to share my personal experience. When preparing this lightning talk, the first question that came to my mind is, when is my start point of open science? I'm aware of the concept of open science is just 3 or 4 years ago, when I started using the openly large data sets. But when I run a self-reflection, my journey actually started when I was an undergraduate in a middle-ranked university in China. I majored in psychology, and most of my modules were quite limited by the textbooks. To get a better understanding of what I was learning, I asked for help from Google. It provides several professional forums where people could ask and answer statistical questions, experiment design questions, as well as the coding problem. If you are originally from China and similar as my age, maybe you could recognize some of them. Besides this, I figured out some online free courses which really brightened my world. So a summary of my first step of open science. Please don't be limited by the resources provided to you by default. Just type your questions or confusions into the searching engine and enjoy the colorful open science beyond what you may have expected. To be honest, I learned my coding skills mostly from Google. Then the second question is why I want to play a part in open science. Open science is not only about learning from others, but also sharing with others. I want to share what I have learned and gained during my search journey. To be honest, I did not have a strong motivation to share with others till I joined the open science community 2 years ago, especially the Chinese Open Science Network. I met with a lot of peers who are so enthusiastic to share and to introduce the scientific hot pies to young scholars in the Chinese-speaking community. Our community provided open tutorials, open talks, the latest open science news, etc., etc. We welcome everybody to pass by our website. If you use WeChat, you may want to connect with us via the WeChat subscription. And maybe you want to look for our channel on Bilibili. So here I am. This year, I'm in the team of vision control and code testing. The main reason I accepted this topic is I want to share my thoughts with the audience who wants to pick up coding but a bit afraid of it, particularly the ones from social sciences. As I say, I was trained in purely psychology without professional tutoring in coding. The open tutorials and talks help me a lot, and so do you. I wish you could enjoy our training sessions this year. All questions are really welcome. And again, I will be very grateful if we could get in touch with each other. So knock the door. Open Science will amaze you. Thank you very much.
Hi, my name is Stefan Yennes, and I would like to ask, for whom is our science open? We talk about open science, but in many ways our efforts to improve the transparency of our research reproduces the same closed systems that hurt and exclude large parts of our society. This leads to a culture of unjustified power differentials, which on an individual level enables bullying and harassment in academia, and at a societal level means the needs, the ambitions, and the talents of historically excluded people continue to be ignored. I would like to join the voices of innumerable activist groups who are working to bring justice to the people they represent. We have a responsibility to listen to their messages and to understand how we as scientists, or as open scientists, are complicit in supporting the injustices that cause us all harm. I will start by reflecting on what I think is wrong with our existing focus on outputs rather than people in open science, and then I will present a series of questions we can all ask ourselves in order to prioritize radical inclusivity in open science. To most people, open science means open access publishing, sharing your data, sharing your code, essentially giving people a lens into your research outputs to verify their quality and to extend rather than reinvent the wheel. The focus is on outputs, but we have largely overlooked the systems and the people that go into creating them. Does it matter if a PI shares all of their lab's code, if they've made every woman in the building feel uncomfortable, degraded, or vulnerable as they've carved their way through a rockstar career? Or what good are my terabytes of shared data when the entry price for a secondary analysis is $1 million infrastructure? But there is nothing new here, right? Rockstars will always be idolized for their art, while their petty misdemeanors or willful ignorance of systemic inequalities are swept under the rug. The people with the money will always have the freedom to do more and to direct the conversation. This is just the reflection of the society we live in. A society where racism, sexism, bullying, elitism, exclusion, homophobia, transphobia, ableism, classism, and narcissism are the norm. We as scientists operate within the context of this society. We are part of it, and we inherit its systemic biases and inequalities. Where we fail is in our refusal to observe and to reflect on our position in society and to take the steps to fix the system. Because to do so would mean accepting that the system in which many of us have flourished is broken, and acknowledging that it is breaking others on a daily basis. When you are accustomed to privilege, equity feels like oppression, so why not hold on to that power, right? So I ask, for whom is our science open? Not for those who have been driven out of science because of this power differential. Not for those who are considered too unimportant or too different. Not for those who are not white enough, not male enough, not cis or straight enough, not able enough, not English enough, not rich enough, not westernized enough, not prestigious enough, not old enough. Not for those who have too many caretaking responsibilities or mental health problems. Am I missing anyone? As Audre Lorde tells us, the master's tools will never dismantle the master's house. So if we want to operate in a system where our science, our aptitude, and our interests are not judged based on some criteria which we have no control over, we are going to have to take some responsibility for fixing the system ourselves. What we're aiming for is a radically inclusive scientific practice. Sure, reproducibility is cool, but have you tried a revolution of compassion in response to a humanitarian crisis in academia? Where do we start though? These are complex systems, so there will be no easy solutions. Instead of a roadmap to success, I would like to offer you a list of supplies for the journey, to keep your energy boosted and to keep your focus on the goal. These are questions to ask yourself when you are writing a grant or starting a research project, when you're collecting data, when you're reading or reviewing a paper, when you're mentoring students or attending a conference, when you're conducting any of your daily activities as a researcher. 1. Who are you excluding? If your research is about autism, for example, shouldn't autistic people be part of the planning to help prioritize the goals of this research? Aren't they the people who have the best context for which initiatives help and which ones hurt? Or if you're investigating new ways of distributing resources in a country in the global south, were experts from that region involved at all? Who might you be hurting? Number 2. Remember to prioritize the people behind the outputs and to know that your words and actions can have impacts in ways that you didn't intend. If you develop a machine learning algorithm to classify people into different groups, have you thought about what this classification would actually mean for those very real people? And what would it mean if a government decides to consider policy changes based on your work? Would doing so risk causing these people harm even if you didn't intend it? 3. Are you distributing the power? Or are you just ticking the boxes for diversity, equity, and inclusion? Are you asking, for example, the only 2 black women on staff to lead the committee and to do all of the work while you ignore their recommendations? If you are doing work that could influence the circumstances of people from a specific group or shared identity, are you giving them real power to change things? 4. Are you listening or are you centering yourself? Reactive or defensive responses are to be expected, but remember that this is not about you. You didn't make the system the way it is, but you can help make it better. If you feel hurt by criticism leveled against you or people like you, especially if you are in a position of relative power, listen to and learn from the people who tell you that they are hurting or being excluded. Listen and then work together to fix things. 5. Is what you're doing reinforcing the existing power structure? The academic system as we know it is inherently competitive, hierarchical, and elitist, but our ultimate goal as scientists is to understand nature and to improve lives. So, are your new initiatives, even if structured to promote open science efforts, falling into the same traps? There are many more questions we can ask, many different approaches to follow, many topics we could focus on. But let us keep asking ourselves these questions. Let us use that to energize ourselves on the journey to a radically inclusive scientific practice. Thank you.
Hi everyone, my name is Martina and I'm one of the Open Science Fellows of this year's OHBM edition. And today I'm going to be talking a little bit about my open science journey. Currently, I'm a cognitive neuroscience PhD student at the Ernst Schumann Institute in Frankfurt, Germany. And I'm working in understanding how the brain processes abstract information using deep learning models. But I'm also a core contributor of the Turing Way Guide. And in case you don't know it, the Turing Way Guide is an online guide to reproducible, ethical, inclusive, and collaborative data science. And it is also an open source project, meaning anyone can collaborate in its development through open platforms like GitHub. And we are also a community that regularly meets to discuss all these topics. So if any of these sounds interesting to you, you're more than welcome to join us by using any of the links provided in the Turing Way website. So in cognitive neuroscience, the Turing Way is mostly known specifically for its guide for conducting reproducible research. And some of you may be familiar with this table that defines what reproducible research is. The Turing Way Guide defines reproducible research when independent researchers use the same data, code, and analytic steps as the original research and obtain the same reported results. This is different from replicable research where the data set is different but similar and the analysis is the same, or robust research where the analysis is different but similar and the data set is the same, or generalizable research where both the data set and the analysis are similar but different. And one specific aspect of reproducibility is computational reproducibility, and this is mostly what I've been working on and talking about lately during online events. Computational reproducibility mostly entails making sure of 4 things. One, to track the changes you made to your code through version control systems, to write clean, understandable, and error-free code, to save and share your computational environment, and to properly make your code open source. And if you're interested in any of these topics and you want to read more in depth about them, you can follow the link that I'm providing here or by going to the Twinway guide itself. I'm particularly keen on understanding how to improve the computational reproducibility of studies in cognitive neuroscience that use computational models, such as, for example, studies that use artificial neural networks to probe human cognition and brain activity. And this is a topic that I've been collecting information about, and we are currently working on adding to the Twinway material reproducibility of machine learning models in general. So if you know stuff about it, or you're interested in the topic and you want to help out, get in touch with me or the Twinway itself. And in addition, we're also planning the development of project templates for different types of computational modeling research projects with the help of the cookie cutter tool, an idea that was born out by participating in the Open Life Science program, which I recommend you all to check out if you are interested in open science topics. And I want to close my presentation by saying that improving reproducibility is only a small part of the work we can be doing to advance the way we conduct scientific research. For example, the fact that research progress is reproducible doesn't ensure that the paradigm or the analytic steps taken by the study are a good way of tackling the scientific phenomena of interest, and this requires another discussion. Similarly, how to ensure that our work is replicable, robust, and generalizable is also a different discussion from ensuring its reproducibility. And luckily, a lot of great research is already being carried out on the limits of reproducibility. And my hope is that this discussion continues to move forward. And with that, I want to thank you all.
Hi everyone, my name is Marta. I am a final year PhD student at the University of Surrey. It is my pleasure that I have been selected this year's fellow of the Open Science Special Interest Group, and that means that I will be leading some hands-on sessions during the Open Science Room. And my sessions will be focused on facilitating open research through community building. So mostly about bringing people together and seeing how this helps us to implement open research practices. If you are interested in these slides, my OSF link is down the bottom. This will be just a quick introduction to the things I will be covering in my sessions. So I think that open science can be facilitated with good community approaches, community that is supportive and community that is collaborative and has generally a positive culture. And this is mainly because of the perceived open science costs. And I divide those open science costs into kind of two main categories. The first one is the fact that open science approaches require additional time and effort, and time is something that we generally lack, and we already put a lot of effort into our work as it is without thinking about new practices that we are not familiar with. And in addition, changing our habits, or it's often perceived as having to change our habits in order to do open science, this makes people nervous and a little stressed. So those kind of arguments are something that I hear from people who are quite skeptical about their ability to apply open science solutions in their own work. And I think that those difficulties and kind of costs that people perceive can be alleviated and made better, so to say, with a supportive community. And I will go into a bit more detail about that in a minute. On the other hand, the other costs that are also worth mentioning is the fact that we might feel a bit more vulnerable to criticism and scrutiny. And we might be worried about the fact that our credibility and reputation might be undermined if we put our work out there and make our errors and mistakes readily available for people to reach for. Will this have a negative impact on my future? And will people still perceive me as a good researcher if they find this? So in one way, we are changing the culture of academia and of science to be understanding towards errors. And one thing that we're trying to say is that we're all learning from one another, and errors are a normal thing. But also we're trying to encourage collaboration. So joining forces in order to strengthen science from the beginning, really. So in my sessions, I will be covering kind of elements of supportive community, which give you an opportunity to learn about the issues surrounding open science, some issues that you might have not considered before, those that you weren't aware of, learning new skills and training in methods that can help you to make your work more open or reproducible. And once you have trained and applied those skills, then you can share your knowledge with your network to also show them what you have done and how you have improved your work through this. And you come a full circle from first finding out about the issues, then learning how to solve them, and then sharing with others how they can do similar things as well. And then on the other hand, the collaborative culture elements that are quite important for me is the fact that you can invite different points of view, and you can make it more of a team effort to figure out some of the issues that you might be struggling with. And that gives you more confidence in your own work, because your work is not just you as an individual, it's a product of a community. And that might as well help to improve the efficiency, because it might be quicker to develop some solutions through hackathons, for instance, and disseminating those solutions to other people in a sort of ready-to-use format as well. So I hope that you can see here how community really helps to build and facilitate open science culture. If you have any more questions and you would like to find out more or discuss this in a bit more practical way, make sure to reach out to me, and here is my email. And I'm sure, I'm hoping to see you around at the Open Science Room sessions and activities. Thank you.
Hi, I am Brian Nosek. I am pleased to be here with you today to talk about issues in open science. What I'd like to spend time on is in addressing what has become well known as factors that create a dysfunctional research culture, reward systems that favor novelty, positive results, neat and tidy results, opportunities that we have to leverage chance inadvertently or intentionally to try to promote better publishability and reward at the cost potentially of credibility. And what I'll spend time in my remarks is on what are the solutions and what can we start to do about improving the rigor and credibility of our research using some of the ideas and opportunities that open science offers to us. So let me begin by just a very brief point about the challenge that we face. This is a graph from a recent review paper we have of research in psychology and related disciplines, looking at attempts to replicate published findings in the literature, either through systematic replication studies, where a sample of papers is identified and as many replications as possible can be done on that sample of papers, or multi-site replications, where a particular finding or phenomenon is identified and it's replicated in lots of different laboratories to get a very precise estimate and to investigate whether heterogeneity in observing the phenomenon is observed in effect size or just even detectability. And what these various investigations have found is that the published literature is hard to replicate in some cases, and the effect sizes observed tend to be smaller in replication attempts compared to the original findings. Each of these is showing that when below the line, the dotted line, are effect estimates of the replications that are smaller than the original studies. And open circles are those where, in fact, the replication showed a non-significant effect or an effect in the opposite direction as the original study. And those solid circles are significant effects, though sometimes with reduced magnitude compared to the original. And across these various investigations, what we've tended to see is that a subset, slightly less than 2/3, are replicated successfully compared to the original. And there tends to be reduction in the overall effect size across the various domains examined, the replications being 68% as large as the original studies on average. So that's just an illustration of some of the things that many different scholars have talked about as potential challenges of the outcomes of some of the factors in the research culture that favor novelty, that lead us to ignore null results, that lead us against conducting replication studies because of the demands of innovation and promoting new findings for advancing our own careers. But also in the discussion of the movement about open science is how we might promote solutions that can improve the credibility of our own research and then the published literature writ large. And there's a variety of things that one might address. The ones that we tend to focus on are making data more available so that you can check whether you can reproduce my findings, that you can subject that data to different analysis pipelines that are also reasonable choices to see how robust my findings are, and so that you can aggregate that data with other similar data to get more confident, more precise estimates combining across studies. Open materials so that you can more easily see the protocols that I use to collect my data, the methodology that is actually what was implemented rather than the summary that I present in the paper, and to make it easier for you to conduct replications that are closely aligned with the methodology that I used in my own research to extend increasing speed of establishing replicability of findings. And then the third is pre-registration, me committing in advance what my research plan is in terms of design, in terms of what I will and how I will analyze the data and what I will report, so that it's very clear to you as a reader which of the parts of my research that were planned, where the statistical inferences have higher diagnosticity about the finding and claim, and which were the things that were unplanned, exploratory, discoveries once I got into the data, which are likewise very important for sending the research in new directions, but are usually more uncertain in terms of the confidence that we will have because they were found in interaction with the data itself. The other potential benefit of pre-registration is to eliminate publication bias so that you can see all of the attempts that I made in investigating a particular question or phenomenon, rather than just those that ultimately got into the paper for publication. So there's a record of all of that research. So an obvious question in this broad discussion about these various types of open science activities is whether they are effective. Is it the case that adopting these behaviors, some of which require changes to our workflow or additional effort, do they have payoff? And one of the studies that has been done to investigate that did a kitchen sink approach. Let's adopt all of the behaviors that we think would be rigor enhancing and see if they have a positive impact on the replicability of the findings that emerge. This is work that was done in collaboration between 4 laboratories, mine at the University of Virginia, Jonathan Schooler's at UC Santa Barbara, Leif Nelson's at Berkeley, and John Krosnick's at Stanford. And what we did in this project over the course of 5 years was each lab did its own research, novel research trying to discover new things in our areas of expertise. And every once in a while, we would find something new, as research labs ideally do, and it would be eligible for submission to this prospective replication study. And eligibility was it had to have a particular type of methodology. It had to be an experiment with 2 conditions so that it could fit into the overall project. So if we discovered a new finding, we submitted it, and then it went through round-robin replication with the other labs. Once we had submitted, I forgot to say that we had to submit this study to a confirmatory test. So we did our work in whatever way we wanted to do our work, very exploratory. And then once we thought we had something, we had to commit, it's going to be part of this. We do a confirmatory study that's pre-registered, all of our design and our plan, and then we report that as our primary outcome. And then all of the other labs then get our methodology fully described, and then they implement a replication of that, and including a self-replication. So overall, there were 16 findings that emerged, 4 from each of the labs. And so what that resulted in was 48 independent replications, each of the other 3 labs doing a replication study, and 16 self-replications. After the confirmatory study, each lab had to replicate their own finding. With pre-registration, with materials sharing, with reporting, knowing that other labs were going to conduct replications, our findings are here on the far right for this best practices approach to doing research. What you see is that the findings are very tight on the 0 line, which means that the replication effect sizes on average were very close to the confirmatory studies effect size on average across all of the different findings that were observed as positive results, suggesting that high replicability is achievable. Which factors in this particular design were responsible is not clear, but it at least is associated with we can achieve near perfect. This is the replication effect sizes here on average were 97% the size of the original studies, that's possible to achieve in at least some circumstances in social behavioral research, whereas in the standard literature, we see rates far below that. So that is promising as initial evidence that some of these behaviors may be instrumental in promoting high replicability. There are other interventions that we have observed emerging that may also have impact on the quality and the reproducibility of published findings. One of the most fundamental or interventionist ones is this model of registered reports. So if you're not familiar, we can start here with the cartoon of what the research process is, right? We design a study, we collect and analyze the data, we write the report, and then we publish it. But of course, it's not that easy because there's this barrier of peer review after you've finished writing up the report before it gets published. And of course, in the standard model, all the incentives here make that report as beautiful as possible so that it can get through peer review and be published. But the challenge, of course, is that that peer review is often based in part, at least, sometimes in whole, on the outcomes. Did you get a positive result? Is it a novel finding? Is your evidence neat and tidy? Rather than on the importance of the question, the quality of the methodology, and the strength of inference that we can apply. What registered reports does is move that initial peer review to after the design phase. So as an author, I submit to the journal my research question, my introduction, background, why it's an important question. I might submit some preliminary evidence, a few exploratory experiments to show that I have some viability here, something worth investigating. And then the proposed methodology of the things that I'm going to test to answer as best I can that research question. And then what the reviewers evaluate is the question important? Do we need to know the answer to this? And is the methodology an effective test of that question? And if it passes that peer review, then I get, as an author, in principle commitment from the journal that they will publish my findings regardless of outcome. So then I do my research, I submit the final report with the findings, and then the reviewers get it back to evaluate not whether the results are interesting or exciting or novel or what I expected, but did I do what I said I was going to do? And did I interpret the results responsibly? So this shift changes fundamentally what I'm rewarded for in how I do my research. And I'm not rewarded for exciting findings. I'm rewarded for investigating important questions and designing effective methodology to test those questions. And what it may also then do is change some of the outcomes that emerge in terms of the credibility, reliability, rigor of the research. And so there's a number of investigations that have evaluated the first registered reports that have been published. This model started in around 2013, and there are now more than 270 or so journals that have adopted the registered report model, but they're still in early stages in terms of the actual outcomes of research that's gone through the model. But of that initial research, there is a lot of promising evidence that it is in fact addressing credibility and rigor of research. So for example, this is work by Ann Scheel and colleagues that compared standard reports published in the same journals around the same times with registered reports on whether the findings supported the initial hypothesis that was motivating the research. And standard reports show what we see when you look at the literature in general all the time, which is almost every paper supports the investigation that it reports having investigated, right? Everything is positive results. We're always right about what it is we investigate. More than 90% of the findings support the hypothesis. With register reports, where pre-commitment is made before we know what the outcomes are, only about 40% of the initial hypotheses are supported in the data as it emerged. This is showing how register reports removes publication bias, right? We aren't rewarded for just getting the positive results. We don't have to refashion our story. We don't have to leave studies out. We just report what we found. We all agreed that the question was important. We wanted to know the answer. Here's what we found. And so this addresses that gap of reporting bias. Now, of course, when some observe these results, especially editors, they might say, oh, that kind of makes me reluctant to adopt register reports in my journal because then I'll have all of these negative results and people don't like negative results and they might not cite them. And whether we agree or not with that rationale, it is a reasonable question to ask, are register reports cited less than regular standard reports, given especially that so many more have negative results or outcomes that are different than what's hypothesized? Well, in this investigation, we looked at 3 different citation databases, Google Scholar, Scopus, Web of Science, and compared standard reports with register reports from the same journals published around the same time. And 100 here would indicate that register reports and standard reports are cited about the same. And above the line indicate that registered reports are cited more often than standard reports. So across these 3 databases, what we see is at least no difference. If anything, there's a slight favoring of citation rates for registered reports over standard reports. Now, that may mean that people doing citations don't care about whether results are positive or negative. But it could also mean that the information in registered reports is perceived as more important or more rigorous or more diagnostic, compensating for the fact that some of the results are negative results, or many of the results are negative results. We can only speculate on the reasons for citation based on the evidence to date. But one of the obvious things is that if the editor and reviewers agreed, we need to know the answer to this before knowing what the answer was, then any outcome is a meaningful outcome, meaning that it's a citable outcome. So it may just be that by making these commitments up front, it changes our orientation about what kinds of questions, what kinds of data will be meaningful data. It could also be that it actually, by having the review up front, it could also help facilitate improvement in the rigor and diagnosticity of the evidence, because the authors know that it's really about the methodology that will determine whether I get the publication or not. And the reviewers are actually being able to give feedback on improving the methodology before the research is done, rather than just pointing out after the fact all the problems that had been done on the work that's already finished. And the authors just say, oh, great, yeah, we did screw that up, but what can we do now? We're done. So those questions are key for a paper that's coming out any day now, where we evaluated registered reports by constructing a new peer review of papers that were published in the registered report model versus the standard model. We identified 29 registered reports in neuroscience and psychology that fit inclusion criteria. And we identified 57 comparison articles, either the same lead authors of the registered report or from the same journal around the same time in the same topical area. And then we recruited peer reviewers and matched them based on expertise so that they would evaluate these pairs of articles, one registered report, one comparison article, either same authors or same journal. And then they had to evaluate those as a peer reviewer does, but with a structured protocol where they had 19 outcome criteria where they rated the papers on and could also provide qualitative comments. What we observed was that registered reports on average performed better than standard reports. So what you're seeing here are Bayesian credible intervals on ratings between register reports and standard reports across these various categories. And to the right of the line is better performance for register reports over standard reports. And to the left would be better performance for standard reports over register reports. So these are all the outcomes where they evaluated before knowing the actual results of the paper. So register reports were perceived as more rigorous methodologically, better quality, we're going to learn more, questions are better, etc. Then they read the actual outcomes, and then they evaluated again on additional criteria. And again, register reports were evaluated as having higher rigor of the analysis, better justification for the conclusion, better quality of the results, despite the fact that many were null, and more amount learned, etc. And then they read the abstract and the title and provided overall evaluation. And again, registered reports perform better than the comparison articles on overall quality and even the importance of the discoveries, despite, again, the fact that many of them are negative results. So this all suggests that this model can not just address publication bias, but may actually also improve the rigor and credibility of the work because it changes what we as authors bring to the table, what we focus on in promoting the best research and doing the best research that we can. So I want to close with just pointing out that these are different examples of behaviors in the movement toward open science that can promote rigor and credibility. But there are obviously lots of different behaviors that are part of the open science discussion. And it can feel quite overwhelming to think about how to get started. Where is it that I can begin? Because it feels like an all or none. But it really isn't all or none. Open science behaviors is just like other behaviors in our training and improvement as researchers. Doing good science is a constant exercise in self-improvement. We're always looking at new methods, new analysis approaches, new styles of research to do better today than we did yesterday. And open science is no different in that regard. So there are lots of different ways to get into starting with open science behaviors. And here are some examples depending on where your interests are and what might be the most effective or interesting way to get started. There's a great review paper by Cruel and al. Just giving an annotated reading list of 7 different ways to get started in open science. There's a review paper that could be the basis of discussion of why open science that reviews the existing evidence about replicability and reproducibility. If you want to learn how to share a preprint, Moshantz has a great preprint about how to share preprints and all of the different factors to consider. Likewise, sharing data and materials, there are great intro papers for that. And now there are infrastructure and resources for starting on pre-registration or trying out a registered report or just getting access to much more information. So here are some links to some of the things that I mentioned. And if you take a screenshot, these slides are also available at the link at the bottom. And I'll be happy to engage with you further if you are interested in these issues. So there's my contact. Thanks very much for your time and attention.
Thank you for assisting to this educational session. Unfortunately, Brian Nosek was not able to be here, but as he already said in his slides, the information that you can contact him for further questions, or you can look at the slides that I think Adam Thomas just put.
Hi.
Hello.
I'm not sure if we're supposed to say something for someone.
Hello, everyone. Yes, so we have few time for our live Q&A with you. So if anyone has questions, please feel free to ask. Also, please feel free to add some further information about what are you expecting about open science, about how your contributions are supposed to advance the field of science in general. And those will be some interesting points to cover.
I guess I can start then. So in my situation where I have been placed, which is talking about community building and collaboration in academia, my goal for a contribution would be to draw attention to the negatives or current negatives of the culture and competitiveness in academia, and explain and empower researchers to understand that it doesn't have to be this way. We don't have to comply with the old ways of doing science, and we have to think about what we can do, small steps without putting too much risk on our careers, to improve this career, because we are the future of academia, and we want to make it better for ourselves. So hopefully this is a positive that we can take from my approach this year.
I don't know if I would add anything else to my talk per se, but it seems pretty clear to me that we need to have these conversations surrounding like the systematic biases or like the culture that we are in for doing reproducible and open science, which I think that we are greatly missing from these conversations or these conferences, but it's so nice to see them like these topics being on stage again.
I feel kind of obligated to say something. Yeah, if anyone wants to chat individually about my talk, you're welcome to contact me on Mattermost. But in general, yeah, the talk could have been much longer, although I tried to cut so many parts to make it fit in the time. But I think my message is that, yeah, that we in science, we reflect the same problems that we find in larger society, and there's no reason for us to think we're kind of special in that sense. And we really need to work hard and see what other approaches people have taken in larger society as well to fix things that are like systemically broken. And it's hard. And I think on an individual level, people need to decide whether that is something they want to do and are willing to do. And they have to kind of repeatedly keep asking themselves the questions, perhaps some of the questions that I suggested, or others that could also be helpful. And from my personal experience, I think this is quite difficult, just because you grow up in a biased world, and that kind of not infects, but you kind of get built, your components build up this kind of biased person, not of your own making necessarily, and you need to work hard to kind of to break them down into parts that you think are helping society grow and parts that aren't. And that kind of self-reflection is sometimes quite painful, but I think it's needed. And that also speaks to why I think that things just kind of persist, because it is that difficult to work on yourself and also on society. But I think it's very important that we do that. So I also posted a blog, a link to the blog post, which is essentially the same words that I said in the video, and that is in the chat and on Twitter. Thank you.
Thank you, guys. It seems like you are not only very young people, but are really, really pushing open science. So it's great to see that such a movement is starting from the very bottom of it. But what will be your recommendations for people that are even younger than you, just very, very at the beginning of academia, or thinking about starting an academia and career in academia, to try to take it more naturally? Like, yes, there are problems in open science. It's not generalized still, but how can we try to achieve that, like on a relatively short term.
I can say something if someone else doesn't want to go first. So I think an important part is getting to like a place where you feel safe to express your like either concerns or just unknowns or things like that, or just your opinion. And I think that is what communities play a big role in. So what Martha was talking about. So I think finding a community like that, which I think now compared to, I don't know, 10 years ago is perhaps easier when we focus on the open science aspects. That I think is useful. Like jump into an open community that you feel you're safe to express your concerns or ideas, and that they're well received. And I think something that bothers me a lot is that people, like I said in the talk, people focus a lot on outputs rather than the process that builds up to those outputs. And we need to continuously remind ourselves that it's a process, and someone is not necessarily a hero because they do open science, or someone is not necessarily a villain because they don't do open science. Most of what happens in the space in between those extremes. And we need to remind ourselves that anyone might be, at any particular point in time, might be in that space, on this kind of spectrum in between the extremes. And we should continuously say, this is a process. Okay, which small thing can I be doing better at that point in time? And not, crap, I haven't put my preprint out, so I'm a bad open science person or something. But it is difficult to not be self-defeating in that sense.
It's a very interesting, good point of view. Marta, do you want to say something?
Yes, I just wanted to mention that during my workshop last week, I actually had a couple of master's students who were just on a journey to start a PhD, and that was very lovely to speak with them about the issues surrounding open science. And some of the things that we discussed was actually engagement in communities and seeking support from people in a similar position, because those are the things that you might not always find an answer for when just speaking with supervisors or people who are your advisors and are stuck to the old ways of working and working in a way that is not very compatible with the values of open or reproducible research. But that doesn't mean that you have to continue in those footsteps, because you are becoming your own independent researcher, and it is all part of the journey of learning. So I think that reinstating learning about open and reproducible research and best practices and community in science and academia is an important and integral part of us training as researchers. And I only wish that more students had the opportunity to learn about this.
That's great. Do you, Martina, have something to add?
Actually, like my answer was going to be the same as Stefan and Marta. Community, like the first thing I think you should do is reach for a community of people that are interested in these topics and can help you get started. The only thing that I would add is like, don't forget that this is not just a series of steps that you are applying to your research. Like, I think the most valuable part of belonging to these communities and thinking about open and reproducible science is actually developing a criticism or a critical spirit of like, why should I do this way, or what is the best way that will be the most beneficial to all of us, not just people who, as Stefan very rightly pointed out in his talk, belong to particular communities that are overrepresented here. So even like the majority of our talks, including mine, tend to outline a series of steps that you should do in your research to be more open and reproducible. I think it's not mainly about that. It's about the critical spirit.
Agreeing with that. We are a little bit short of time now, but I was just wanting to bring to you this question, which I think it's also important. This is from Gerda Vorcova. Sorry if I didn't pronounce it good. And do you have any resources to recommend on the topic of how capitalism affects, shapes science, and what are your thoughts on the subject, if any?
I'm also interested in getting resources if anyone has. But my quick thought is that I don't like the way capitalism affects most things that we experience, and that is because basically everything is about how the incentives structure or prioritize what we should be focusing on. And in my opinion, that according to capitalism is quite short-sighted, because what's your best, quickest return on investment based on what the incentives say? And that is a weird way to prioritize what we do in science, especially if we say that we care about individuals.
I think that the topic is generally under discussed and overlooked, and we should have more of a discussion on this for sure. And it does affect us all, although sometimes we don't really pay attention to it much. But one of the things that I have noticed where my research is the most impacted by this is when I try to talk about my research, recruit participants for my research. I've noticed some labs have started branding the research projects and have really cool project development sides where they're really attractive, eye-catching, and people want to be part of this. Some other people don't really have the skills for that, and it's a big gap. So we need to discuss this. I don't have any resources. Sorry.
Just a short answer to that. I think that some people at the Doing Way are working on a chapter related to this stuff. So probably it's coming at some point discussing this. And a little bit later, I think here in the Open Science Room, Olivia Guest will come and talk. And I think she's interested also on these topics and has written about them. I don't know if about capitalism, but about colonialism, with kind of like is another side of the same coin.
Oh, sorry, I was muted. Thank you everyone for your kind answers. We need to keep going further to the next question, to the next educational session, sorry, which is from Brian Nosek. I will be happy if you stay around in the chat in case someone else wants to keep discussing. Perhaps if there are so many questions, we can try to book an emergent session for this. So please feel free to keep enlarging the discussion.